Alright guys, we're going to look at factoring in this video, and we're going to do it in kind of a comprehensive way. So we're going to start off fast with hopefully some easy stuff and then work our way toward a little bit of the harder stuff. So starting off, all factoring is we're going to try to take something and break it into its most basic components. That's all we're trying to do when we factor. So we look here, we've got this number 6, and if we want to factor this number 6, get it into what we call its prime factorization, or its most basic components, what we really want to do is break it down into the numbers that are being multiplied together to get that number. So I'm looking at 6, and I know that I can break that down into 3 times 2, and those numbers are both prime, so I've factored the number 6. So let's step it up a little bit, and we'll throw a variable in there. Now we're looking at the number 6a, and we want to factor this number. If we want to factor it, we just want to take a look at what's being multiplied together to get it. So we just did 6, and we know that 6 can be broken down into 3 times 2 or 2 times 3, and we also have an a in there, so the factored form of this 6a is 2 times 3 times a, or the prime factorization. So the next step is we start adding multiple terms, and remember, terms are usually distinguished by an addition or a subtraction sign. So I've got 2 terms here. My first term is a 2x, and if I break that up, I get 2 times x, and if I break up the second term, it's just 2, or we could actually say 2 times 1. And as much as I don't really like to, we don't write the times 1, I'm going to throw that in there, and you'll see why here in a second. So when I factor this thing, I'm breaking it up into its most basic components, but I'm also pulling out any common components. So if I look at this thing, I'm looking at this 2 right here, and this other term also has a 2 in it, and this is called the greatest common factor, or the GCF. So what we want to do is we want to take that greatest common factor and pull it out front, and then write anything that's left over on the inside of the parentheses. So if each term has a 2 in common, I'm going to take that 2, and what's left inside after I pull the common factor out is I've got an x left in the first term, and bring my plus sign down, and I've got a 1 left in the second term. And so the factored form of 2x plus 2 is just 2 times the quantity x plus 1. So going forward, this is going to be the thing that we're going to look to do first, kind of because it's the easiest. We can generally see, you know, maybe you have to write the factors out, maybe you don't, maybe you can kind of look at that original expression and see, hey, that's got a 2 in common. But we're going to start with the greatest common factor. So let's go ahead and go forward with this one. I've got 6m plus 12. I'm going to break down the 6m into a 2 times 3 times m, and then the second term, the 12, can be broken down into its prime factorization of 3 times 2 times 2. So we're going to start with the GCF, or anything that these 2 terms have in common. I see a 2 here. I see a 2 here, so I can pull one of those out. And I also see that it has 3's in common, so I'm going to pull that out front. So technically what this looks like is a 2 times 3 goes out in front. Over here, what's left is an m, and what's left over here is a 2. And simplifying that, I know that 2 times 3 is 6. So 6 times the quantity m plus 2 is what I'm left with for my factored form of 6m plus 12. Alright, as I said, we're going to kind of build up, so let's take a look what happens if we have squared terms. Well, I've got this x squared, and I know this x squared can be broken down into x times x. That's the prime factorization of that one. Second term has just 1 x in it, so what do these have in common? Well, they just have 1 x in common. And again, remember, this is technically x times 1. Use that 1 as a placeholder, because when we pull this x out front, we have to have x times x plus 1. That quantity. So that's my factored form for this one. So just to review, for greatest common factor, anytime you're factoring anything, looking for a greatest common factor is always your first step. So if you'd like to get a little bit of extra practice, you can go ahead and do that. Try these. You can pause the video, try them on your own, and when we come back, I'll give you the answers. Alright, so hopefully you've had a second to try those, and here are the answers for those ones. Go ahead and, if you'd like, you can pause the video, check your answers, make sure you got all the correct answers there. And if you missed any, go ahead and check your work, make sure you go back and look at that prime factorization. Alright, so hopefully that was pretty easy for you, so let's go ahead and move on to a little bit more difficult stuff here. This one, we're still looking to factor, so the first thing that we're going to do is we're going to look to find the GCF. And if you look at these three terms, there is nothing in common between these three terms. This is called a trinomial. And so when we get to the trinomial, our first step is still to find the GCF. And if there is no GCF, there's a little bit different process for this, for factoring this. So when we're factoring these trinomials, the process is this. We don't have just one set of parentheses like we did back in these problems down here, when we just had a single term outside being multiplied by these things. What we're going to end up with are two sets of parentheses. So the easiest way that I've always found is go ahead and just set up dummy parentheses. Now, we're going to start with this first term, and we're going to look at, all right, what do I need to get in order, or what do I need to multiply in order to get this first term? Well, I know this is x times x, and so these terms go in this first slot in each set of parentheses. The next thing that we're going to do is we're going to look at factors of the last term. And so when I look at factors of the last term, well, this is easy. This is just 1 times 1, so that goes in this last slot right here. And the last thing I need is I need my two terms over here to add up, or when combined, to give me the middle term. And so I know that 1 plus 1 is 2, so that kind of confirms that my factored form of this trinomial is x plus 1 times x plus 1. So in order to confirm this is basically double distribution, and a lot of us have probably learned it as FOIL. So I'm going to take this first term here, and I'm going to multiply it by the first term in the second set of parentheses. And x times x, so again, we're just checking this to make sure that it works, that it gives us back the original. X times x I know is x squared, so that's a good start. We got what we needed up here. And then I take my x and I multiply it by the second term, or by the last term, my first term times the last term, or in other words, outer terms. So that gives me a 1x. I do the same for the second term here. I make sure that I multiply my second term by each term in the second set of parentheses. So this is 1 times x, or the inner terms. And then the last part is this needs to also be multiplied by the last term. So 1 times 1 is 1. I go and combine my like terms, and I end up with something that looks exactly like the original, which is perfect. So I factored this correctly. I've just changed the form of it, and we're good to go. So again, just to review, we always look for the greatest common factor first, and then the second part is if it is a trinomial, I've got two binomials. If it can be factored, I'm going to have two binomials that are multiplied together. So I go through this process. So let's go ahead and look at another one here. I've got a squared plus 8a plus 12. So the first thing is always GCF. There is no GCF. There's no greatest common factor that I can pull out front. So I go ahead and I say, all right, if it's a trinomial, it's going to be two binomials multiplied together. So set up your parentheses, and now let's look at the factors that are going to give us this. So the first thing is I look at my first term. I know that's a times a. Those go in the first slots of each set. And now I look at the factors of this. Well, this is a little more difficult because there's more than one set of factors that are going to give me 12. So I can start off with 1 times 12, and 2 times 6, and 3 times 4, and that's all of them for 12. So the last step here is I need two factors that are going to add together to give me my middle term. So they have to add together to give me 8. If I look at 1 and 12, well, that's 13. 2 and 6, that'll give me my 8. 3 and 4 would give me 7. That's close, but not quite. So 2 and 6 is going to be the combination here. So I throw those in to my second part, and all these are going to be added together. So this is my factored form. Again, you can check it by foiling it if you'd like. You can go ahead and pause the video and do that if you'd like to do that, but you should get this original expression. Alright, let's take a look at another one. This is a trinomial. There is no GCF, so we always check for the greatest common factor first. No greatest common factor here to pull out front, so I move on to the next step. So I'm looking at, it's going to be a binomial times a binomial. My first terms are going to be multiplied together to get this, and I know that's m times m. My two last terms are going to multiply to give me a negative 8, so we got to pay attention a little bit here. So I know 1 and 8 can give me a negative 8. I also know that 2 and 4 can give me a negative 8. So this next step here to figure out which one is actually true is I'm going to look at all different combinations of positive and negatives for my two factors. So I'm going to look at 1 and 8. Is there any way that I can get a 1 and an 8, or I'm sorry, a 7, that I can get these terms to add up to 7 if I use a 1 and 8? Well, yeah, absolutely. If I take a negative 1 and a positive 8, I know that that adds up to 7. So these are going to be my terms, and I carry the signs with them. So my negative 1 I'll throw in this first slot. Positive 8 I'll throw in the second slot. And again, we want to check this to make sure. So I multiply my first times my first. That's m squared. My outer is going to be m times 8. So that's 8m. My inner is minus 1m. And my last is going to be minus 8. And if we simplify that, we see we get exactly what we need. An equivalent expression. So my factored form checks out. Check out one more here. No greatest common factor. Always my first step. So we move on. We move on to the two binomials being multiplied together. My first terms are going to be y times y will give me y squared, so I slot those in. My second one, I'm going to look at all the factors of 12. So 1 and 12, 2 and 6, 3 and 4. So let's check this out. The last thing that I need in order to determine which combination is going to work here is I need those things to add up. I need some combination of these to add up to negative 4. So 1 and 12, no combination is going to give me a negative 4. I'll either get a positive 11, a negative 11, positive 13, or a negative 13. Now 2 and 6, let's check out 2 and 6. If I do 2 and 6, I know that I need a negative 4. So if I do a positive 2 and a negative 6, that's going to give me a negative 4. And that's the combination that I need to use. So I need a positive 2 and a negative 4. And that's going to be my factored form for this one. Again, you can check with FOIL if you'd like, but it should give you back exactly what we started with. Alright, one more here. No GCF on this one again. No greatest common factor. I'm always looking for that to make life a little bit easier. So I go ahead and factor. Put our parentheses up. X times x is going to give me x squared. Next thing I'm going to do is I'm going to look at what numbers, factors of 20, what numbers multiply together to give me 20. And there are, I believe, all of my factors. And the last thing is I need to look at combinations of these with different signs in order to give me a negative 9. Never going to get a negative 9 out of 1 and 20 or 2 and 10. And if I look at my 4 and 5, I can get a negative 9 out of those if both numbers are negative. So those are going to be the signs that I use, and there's my factored form. Alright, last one here. Again, our first step is always looking for a GCF. And if you look at these terms, each individual term, well, it looks like these are all multiples of 2. So I can actually pull a 2 out of this out front. And I mentioned before that this makes life a little bit easier. You can factor these. without pulling the GCF out. They're just a little bit tougher to see the combinations that you'll get. Anytime we can pull that GCF out, we want to do it. So I've now got this 2 out front. So what I'm going to look at is, how can I factor this expression right here? And no more GCF, so we know that that's a trinomial. So we're going to have 2 sets of parentheses. My 2 stays out in front. And now I'm just looking at combinations that give me t squared, and I know that's t times t. Now I'm going to look at the last term. I know that's just 1 and 3, so that's a nice easy one. And it's all positive, so 3 plus 1 will give me my factored form. And there it is. So that's why pulling that greatest common factor out always makes life a little bit easier, because now we've simplified this and we're dealing with a little bit easier numbers.